Today we're going to start talking about trinomials. Yesterday we factored two different kinds of polynomials. One was a polynomial with two terms, which is binomials. One of them was polynomials with four terms, which are polynomials with four terms. Okay? I need to take you back to the flipped video that we watched the other night. I had you think about some numbers. For instance, I need two numbers that multiply to be 10 and add to be 7. If this is our thinking, this is what the problem would look like as a trinomial. Okay? Somebody already said the answer. 5 and 2. If this is the problem, this is our thinking, and we figured out it was 5 and 2, these are the factors. Done. Okay? Let's start with the problem this time. What if the problem says x squared plus 10x plus 24? If this is the problem, what's our thinking? Multiplies to be 24 and adds to be 10. It would be 6 and 4. If it would be 6 and 4, can you tell me my two factors? X plus 4, x plus 6. Okay. What about if the problem looked like this? X squared minus x minus 6. What is my thinking? Multiplies to be negative 6, adds to be negative 1. If that's my thinking, what are my two numbers that work? What kind of 3 and 2? Because remember, it's got to be a negative 6, negative 3, positive 2. Excellent. If those are my factors, if those are my answers, what are my factors? X minus 3, x plus 2. They wouldn't all be minuses because we already decided if it's going to multiply to be negative 6 and add to be negative 1, those two numbers have to be a negative 3 and a positive 2. So when we put them in our factors, they have to be x minus 3 and x plus 2. Okay? Does that confuse you a little? Do you want me to go backwards a little bit? Okay, you good? All right. Let's try another one then. What multiplies to be negative 6 and adds, what did I write? Just the letter B. That's weird. Adds to be negative 5. If this is our thinking, tell me what my problem is. X squared minus 5x minus 6. What's it going to multiply to be? Which term? It's going to multiply to be the last term and add to be the middle term. Okay? 1 and 5 multiply to be 6. Okay, hold on, time out. Somebody said negative 3 and positive 2. Negative 3 and positive 2 do multiply to be negative 6. I agree with that. But negative 3 and positive 2 don't add to be negative 5. So that can't be it. You can't have what? Yeah, I can't. That's why I crossed them out. It doesn't work. You don't have to have two negatives make negative 5. Positive 1 and negative 6. Does that multiply to be negative 6? Does that add to be negative 5? Yes. So what are my two factors? X plus 1, x minus 6. Okay, so can we talk about the crazy kid for a second? The crazy kid earlier, we were on this problem up here, and he said, but Miss Kingston, what I wrote was x plus 6 and x plus 4. What did I say? I said, okay, that's fine, right? Does it matter what order we multiply in? Because what's 4 plus 5? 20. What's 5 plus 4? 20. It doesn't matter what order I multiply numbers in. Okay? So it doesn't matter what order I have these factors in. But here's the other thing. The same crazy kid said, okay, Miss Kingston, that's fine. On this one, it should be fine because this is what I put. Why is that not right? I just said it doesn't matter which order we multiply in. Correct. It still has to be a negative 6 and a positive 1. These have opposite signs of that, and that is not okay. So can you tell me, please, what would be okay for me to write instead of this? X minus 6, x plus 1. Perfect. Okay? Either one of these are acceptable answers. Fair enough? Any questions about that? All right, one more. Make sure we're good. You want to start with the thinking or with the problem? The thinking multiplies to be 12, adds to be 7. What's the problem? X squared plus 7x plus 12. 4 and 3. If 4 and 3 are the numbers, what are the factors? Very good. Any questions? Okay. So what I want to show you real quick, if I can find some more notebook paper. Here it is. Let's start with this problem right here. X squared plus 5x plus 6. Let's do that in our head. We're not going to write anything down yet. Let's do it in our head. What would my factors be? Skip all the middle steps and go straight to your factors. Can you do that yet? What are my factors? So those are the numbers. Tell me the factors. X plus 2 and x plus 3. Okay? We're not going to write it down. I mean, you can if you want. If you already did, don't erase it. Okay? But what I have to do is I have to show you another way. All right? I have to show you another way because in reality, the way that I just showed you, this is a shortcut that does not always work. What do you notice about every single one of these problems right here? They're all squared. That's a good observation. What's the term in front of the x squared? 1. This way only works when the term in front of the x squared is 1. Of the problems we have to do, those are rare. So what I want to do is I want to show you a problem that we already know the answer to. We already discussed what the answer is, right? But I'm going to show you the more involved way to figure it out in case this is not 1. I know it's a 1, okay? But it's still, the other way still works. The way to factor it still works, even if it's a 1. Fair enough? Hey. So here we go. First thing you need to know is that the general form for a quadratic looks like this. ax squared plus bx plus c. That is the general form for any quadratic. To do the way I'm going to show you, we need to know a, b, and c for this particular problem. What is a in this problem? 1. What is b in this problem? 5. And what is c in this problem? 6. From that information, I need to find ac and I need to find b. Well, b's easy. I already know b. I already know it's 5, right? But what's ac? What is it asking me to do with a and c? Multiply them. So what is ac in this problem? Because 1 times 6 is 6. It's the same kind of thinking that we just did. It's got to multiply to be AC and add to be 5. But here is where it's different. Tell me what two numbers multiply to be 6 and add to be 5. 2 and 3, right? 2 and 3. So at this point, I rewrite my problem. I start at the beginning of the problem, but when I get to the middle term, I'm going to split that middle term into two terms. It's not just 5x anymore. It's 2x and 3x. Where did I get 2x and 3x? From the numbers that multiply to be 6 and add to be 5. Very good. Okay? And then I have my last term of 6. You okay with that? Do you know how to factor something with 4 terms? Oh my gosh, I taught you yesterday. What a coincidence. It's almost as if I planned ahead. Look at just the first two terms. What do these terms have in common? What are they both divisible by? X. When I divide out an x, what is left? X plus 2. Excellent. Look at just the second two terms. What are they both divisible by? What do they have in common? A 3. When I divide each term by 3, what do I have left? X plus 2. Are my parentheses the same? Then to get my answer, I write down what I factored out and then what they had in common. And that is my answer. If you'll remember, that's also the answer we said a second ago, doing it the shortcut, isn't it? X plus 2, x plus 3. You remember that? Yep, this is the long way. Why am I showing you the long way with an easy problem? They might not understand the other way. Shortcut doesn't always work, and I wanted to do it on an easy problem. Fair enough? We're going to do it one more time on another easy problem to make sure we have the steps down before we go on. Fair enough? Okay. So what do I need to know first? A, B, and C. What is A in this problem? 1. What is B in this problem? -2. And what's C? -24. So what is AC? -24. And what is B? -2. Okay? So tell me what two numbers multiply to be -24 and add to be -2? Well, let's see. 1 and 24 multiply to be 24, right? 2 and 12. 3 and 8. 4 and 6. So somehow I have to use two of these, like one set of these factors, to make a -2. One of those is right. If it's -4 and +6, when I add those together, I get +2. +4, -6. That's the combination I need. Okay? Rewrite your problem. X squared, I'm not going to write -2x. I'm going to write my other two factors that I know work. Plus 4x minus 6x minus 24. Now I'm just factoring by grouping. Look at the first two terms. What do they have in common? What are they both divisible by? An x. What's left when I divide each term by x? X plus 4. Good. Look at your second two terms. What are they both divisible by? What do they have in common? How about a -6? You remember that from talking about it yesterday? What do I need my parentheses to say? I need it to say x plus 4, right? And if I just take out a regular 6, a +6, I'm going to end up with -x minus 4. And that's not the same, is it? So if we take out a -6, we do end up with x plus 4. Are my parentheses the same? Then I write down what I factored out, and I write down what they had in common. But to avoid confusion, I need to show you one more thing. Okay? I don't expect you to write this part down. What I actually want you to do is watch. You can write it down in a minute if you'd like. Okay? But what I'd like you to actually do is watch. Whenever I get to this step, there's a really, really popular question that I get asked. I decided the numbers were 4 and -6. When I rewrite my equation, sometimes students ask me, does it matter what order you put those two terms in? Did anybody in here think about that? Okay. So I want to just show you something real quick. What if I rewrote it like this? Did I change the problem any, or did I just switch the terms? I just switched the terms, right? So if I'm going to factor by grouping now, what's common in the first two terms? An x. What's left after I divide an x? Good. X minus 6. What's common in the second two terms? A 4, right? And if I factor out a 4, what's left? Good. X minus 6. Are the parentheses the same? Then write down what I factored out and write down what I had in common. So now answer me the question. Does it matter what order you put these two terms in? I got the same answer, didn't I? Good. Okay, so are you ready for this? I bet you are. 2x squared plus 13x plus 6. Can I just figure out what multiplies to be the last and adds to be the middle? Can I do the shortcut on this one? No. Why can I not do the shortcut? Because I have a 2 in the front. So what I need to figure out first? A, B, and C. Can I tell you something I forgot to tell you a minute ago? I mean, we talked about it yesterday. We just haven't talked about it today at all. What's the very, 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 very first thing I need to do in every single one of these problems? Look for a greatest common factor. Very good. Okay. Does this one happen to have a greatest common factor? No. So that's why we're going straight to A, B, and C. I just wanted you to have that in the back of your mind to keep thinking about it. Okay. So A is 2, B is 13, C is 6. So what's AC? 2 times 6. What's B? 13. So please tell me two numbers that multiply to be 12 and add to be 13. 1 and 12. You okay with that? Rewrite. Rewrite the problem. 2x squared, that term stays the same. I split the middle term into those two things I just found, which were 1x and 12x. And then I rewrite my last term, right? So just look at your first two terms, just those two right there. What do they have in common? What are they both divisible by? X. If I factor out an x, what is left? 2x plus 1. Look at just the last two terms. What do I have in common? What do I have in common? A 6. If I add 6, divide each term by 6. What do you have left? 2x plus 1. Are both my parentheses the same? Yes or no? Then I can write my answer, can't I? What did I divide out? What did they have in common? That's my answer. Any questions on this? Let's do another. Sorry. Are you good? Did you get it? Okay, I just want to make sure. 2x squared minus 21x plus 27. Greatest common factor? Are all three terms divisible by the same thing? No. So we keep going. I need to find A, B, and C. Very good. A is 2. Ooh, good catch. B is negative 21. C is 27. What is AC? What is 2 times 27? 54. What's B? Negative 21. Okay? Now, I am very well aware that some of you can do some of this stuff in your head. I'm going to be thinking out loud so you remember where to think and how to think here. Okay? It's got to multiply to be 54 and add to be negative 21. I need to write on paper what the multiples of 54 are. 1 and 54. 2 and 27. Keeping in mind as I'm doing this, I'm trying to get a negative 21, right? 3 and 18. What? Negative 18, negative 3, right? Because they have to multiply to be a positive 54, so they both have to be the same sign. But I need a negative 21, so they both need to be negative. So now I rewrite. Okay? When I rewrite, I get 2x squared minus 3x minus 21x plus 27. Just look at the first two terms. What do they have in common? What are they both divisible by? X. Good. Factor out an x. What do you have left? Good. 2x minus 3. Excellent. Just look at the last two terms. What are they both divisible by? 7? No. Guys, I messed up. Where did I mess up? Yes. This should be 18 right here. Sorry about that. No, I should have known when certain people were looking at me strange. Sorry. Okay, this is a 1. This is an 8. This is an 8. So 18. So now between these two, what are they both divisible by? Even more than 3. 9, right? But I actually want to take out a negative 9, don't I? Because I want my parentheses to say 2x minus 3. You okay with that? Sorry about that. Are the parentheses the same? Then what did I factor out of each term? And what did they have in common? I need to show at least one person something. You. Because you asked about the box method the other day. Can we multiply stuff with the box? You can factor with the box too. Okay. You remember how we set up the box like this? And then we filled stuff in on the outside? If you're going to factor with the box, you do exactly the same thing until here. And when you're here, you fill in the box on the inside with these 4 terms. And then you go backwards and you say, what do these 2 terms have in common? What are they both divisible by? 2x. What do these 2 terms have in common? What are they both divisible by? Negative 3. What do these 2 terms have in common? Or what are they both divisible by? An x. And what do these 2 terms have in common? What are they both divisible by? Negative 9. X minus 9, 2x minus 3. Okay? Now, I know, even when we talked about this the other day, not all of you are a fan of the box method. I get that. Okay? But you know I like to try to show you more than one way to do stuff. And in actuality, if you look through the worksheet that we did some homework on last night and we're doing the rest of it for homework tonight, They actually want me to show you 4 different ways. And you know what one of the ways they want me to show you how to do this is? Guessing. Not even kidding. Like, what the H? What does that even mean? I need to teach you how to guess? I'm not going to do that. We're going to do ways that work every time. The box works every time if you know how to do it. Factoring by grouping works every time if you know how to do it. Okay? Any questions so far? Yes, ma'am. We good? Okay. Last example for you today before we head for our homework. Do we have time? Okay. I need to make sure you understand what homework you're doing tonight. It's just the other 8 questions that we didn't do last night. Okay? Can I show you the first part of this example at least? And I will finish it. Even if the bell rings, I'll finish it, and then I'll load this whole thing on YouTube and stuff like that. Yes, I am still recording. I'll load the whole thing on YouTube so you can watch it later if you need to. What do I do first in this problem? Greatest common factor. Do you notice they're all even numbers? Okay? This is a problem that's different because I got to do greatest common factor first. And if you wanted me to be completely honest, you don't have to. You can factor out stuff at the end. But if we started here and did AC, AC would be negative 160. Do you know the factors of negative 160? That's kind of crazy, right? Whereas if I do it here, my AC is what? Negative 40. Okay? Negative 40. So that's the difference here. Okay? I hope you have a great day, and I'll see you later. Peace.